like to go ahead and get started. Today we're going to have a workshop on SolidWorks for FIRST Robotics, and talk a little bit about our experiences on Project Y with SolidWorks, and go through a quick tutorial to kind of highlight some of the utilization for it and what we do with it. If you have questions that come along, you want to put them in the chat, or just raise your hand. Maybe that's how we'll try to work questions as we go forward. So I'm going to go ahead and do a short presentation. Yeah, Fred.
I hope you'll cover why you chose SolidWorks.
Yep. Yep, I will.
Thank you.
Yep. All right, so, and let me shift that to presentation mode. There we go. Okay. So let's see, go to, all right, so talk a little bit about why SolidWorks. I'll do some short introduction to SolidWorks for FRC. Most of what I'm going to cover today is available in other tutorials that are built into the platform. You'll find lots of stuff on YouTube as well, but I thought it might be helpful to kind of show in the context of FRC robotics how to use the tool. To do a quick part design, we'll create an assembly that would be kind of a basic frame, and then talk a little bit about what we do with it in terms of design testing, show you how to create a drawing. The other thing that we do a lot with SolidWorks is going to be our 3D printing and CNC machining, and I mean, we're not going to have time to go into that today, but certainly you need some sort of CAD package to really be able to do much of the advanced manufacturing. And then I'll show you how to get the access to some of the tutorials to help learn and explore on as you go forward. So first off, why SolidWorks, and touch on that. One, it's a very powerful 3D modeling software. What we have found over the years that we've used it is it's a good entry point. It's not the most sophisticated and complex of the softwares that are out there, but it's kind of a midpoint 3D modeling software that's very powerful. It's far more powerful than anything that you normally use for in robotics design. So it gives you a lot of functionality. And so that gives you freedom and opportunity to explore with that. There are some other packages like Fusion 360 and Onshape that are valuable. I think Fusion 360 and SolidWorks are relatively comparable. They have a lot of similarities. We really like SolidWorks because it's available in a desktop application. Onshape is a web cloud-based platform, and Fusion 360 has some of that as well. And for us, it doesn't work as well to share information. But either of those programs can be used and would be valuable. They both also the SolidWorks. One of the things that I have found with teaching SolidWorks for the students is that it's a very good platform for them to learn on. We've had many of our students that have gone directly from the robotics program into industry and been able to pick up whatever the company or in some of our students working at the National Laboratory pick that up very easily and can move into other platforms. And so it's a really good foundational program. So we think that's a good opportunity for the students to develop the skills and engineering approaches that they're going to see in industry when they go out and start doing engineering in the field. And like I said, the tools and techniques for how to think about 3D modeling and how to apply that are all very similar. They have a little different semantics between the different programs, but once you've started to learn one program, it is transferable. But my recommendation is whichever package you choose, you stick with it, because your mentors need to learn some of the tricks and tips to help the students along. I did also put the license in there for SolidWorks. You get pretty much access to the entire program from from SolidWorks for FIRST, and so it gives you the CNC software is built into it, as well as a ton of simulation stuff that you can really get into and develop and get really in depth if you want to start doing design analysis and going a little bit further in terms of how you optimize your designs. Let's see. Oh, there we go. So one of the things I wanted to just touch on real quickly for us in
Andy?
terms, yeah, go ahead, Fred.
I hope I can jump in here. And if any of my team members are out there, you'll have heard this many times. I'd like to expand a little bit on what you said on Fusion 360 and Onshape. And if you look at industry standards for CAD design, industry uses maybe four primary CAD systems. Siemens, I believe, is probably the most integrated, strongest, most expensive, and better geared to electrical, electronic, sophisticated design, packaging, and analysis. Autodesk, I get the impression, is more construction oriented and probably the weaker of four. And I'm sorry, I don't remember the fourth, but SolidWorks is probably the best recognized general CAD package out there. And my view has been very straightforward. Don't mess with a toy CAD system. Learn an industry standard. It will carry you through your career. And when you begin at a major university and in the industry, or choose to earn a living doing CAD, SolidWorks is a very high standard means of getting there. I deem Fusion 360 and Onshape as nothing more than an academic-centric packages that ease of entry, ease of cost for academia, and it isn't well implanted in major industries. Biased as I can be, you all know that. I probably have 30 years experience in this stuff. And SolidWorks is really proven to be viable for high school students. Those that we have who have done best in CAD, I think are at a point they could make a living doing it from home.
Yeah, we've had many students transition straight from the experience on the robotics team straight into industry, you know, and they're productive almost immediately. So and like you said, Fred, I think it's relatively straightforward to learn how to use, and I think I'll show that here tonight a little bit. Couple of other things just in terms of our design approach for Project Y, we like to use the proceed rapidly to your first failure concept. And work from a design thinking standpoint, in which case, you know, we're really working towards discovery of the problem, interpreting how we do it, coming up with ideas for how we solve the challenge, and then experimenting for how we build it. And one of the things that I feel like SolidWorks gives us a solid tool to really get those ideas down quickly, get them into a practical tool that we can actually then start to look at interferences or things that are not going to work with the design. And it allows us to use sometimes iteration to solve complex problems that we would really struggle with mathematically. Last year we had an arm that came out over the frame perimeter, had to go back inside the frame perimeter, but to get exactly the reach that we wanted to control the element and bring it back within the frame perimeter, it took us a couple hours in SolidWorks just modeling it again and again and again to make sure to change the arc, change the angle, change the length. Gave us a way to approach that problem that I think we would have struggled with any other way, which helps optimize your design for what you're trying to do. So So I'm going to go through now. I'd like to shift over to a little tutorial that I hope will be interesting, but not too overwhelming. And I'm going to show you some of the features and powers of the tool to just create a basic shape. How do you think in 3 dimensions? And then add that all together to create a basic assembly that we could use. And the goal that I'd like to propose as a quick problem for us tonight is to do a frame that we could use for a West Coast drive. I was going to think about, could we then add some equipment and gearboxes? I don't think we'll have time to get into that. And then I'll send this out with a link to some additional tutorials that we have on our website for SolidWorks as well. So I started with kind of a basic frame idea to say, let's build a West Coast drive. Sorry, my dog's barking in the background. Hopefully that's not too bad. And that we have a 120-inch frame perimeter. We're going to build roughly a square frame. We're going to use some 1x1 box aluminum. We use a lot of 1/8 inch and 1/16 inch aluminum for our construction. So today I'm just going to use 1/8 inch just for simplicity. And we're gonna plan to rivet the sections for the outside of the frame, and then on the inside we're going to set that up for a 1/4 bolt through configuration, so that it's easier for assembly and disassembly of your frame. All right, so with that, I'm going to go ahead and stop sharing from this presentation and open up SolidWorks. So hang with me. Okay, so now we have kind of our basic SolidWorks opening point here, and I'm going to go ahead and create a new part. And I know this is going to move kind of fast, so hopefully SolidWorks will cooperate with me tonight. There we go. And you'll see kind of on the main features that we're going to use tonight are kind of features in Sketch. And so those are the things that we're going to focus in on. There's a lot of other tabs here kind of on the top left that can help you go into evaluation, simulation, all kinds of different things. We're not going to really worry about that here tonight. So we're going to use just features in Sketch. On the left-hand side is what's called your feature tree. And this gives you access to a lot of the different information on for your part. This is where we're going to kind of focus some of our time. Before we I'm going to add one person into the waiting room. So there we go. We can start out, we can specify our material. So this helps you if you want to do weight analysis later on for your robot. You can actually run SolidWorks and it will tell you how much each of the parts are going to weigh or what your total is going to be for the robot. So you can come in there. We can edit that material. Has all kinds of different alloys in it that you can work with. We typically work with aluminum 6061, so that's what we can select for our part. So first thing that I'm going to do is, remember we were going to create a frame out of some 1x1 box aluminum, and so I'm going to go ahead and sketch that out. By convention, we typically teach our students to use the top plane for our sketches. And so we'll go in and create a sketch on the top plane. This brings up the face so that we can edit it, and we can come over here and we're going to select our rectangle. SolidWorks gives you different options for different kinds of rectangles that you might want to use. And so to start though, we're going to use what's called a center rectangle. And that center rectangle, when you hover over the origin, which is shown by the 2 red arrows there, you'll see that the SolidWorks comes up with a little dot. So SolidWorks is trying to help you and will give you lots of suggestions as we go along tonight to help you make your part exactly the way it thinks you want to do that. So we're going to go ahead and draw a square. And then because we're trying to make 1x1 box aluminum that's an 1/8 inch thick, we're going to go ahead and add our second square, which is going to be the interior of that tube. So now we've got the rough shape, and we're going to go ahead and dimension it. And we're going to make that 1 inch. Now, I will take a moment here because I forgot to point out down in the lower left-hand corner, you can get the different units. So you can use inches, metric. We typically do everything in inches. And so I'm just going to do that here tonight. Then we're going to go ahead and dimension out the interior of that. And we're going to make that 0.75 because I told you that we're going to do this as 1/8 inch aluminum. And so now because we want to make it a square, the other thing I'm going to show you here is down on the bottom here is a little sign that says under defined. That means you haven't told SolidWorks enough about the part for it to know everything it needs to make that model. And so we've got a little bit more information because we know it's a square, but we haven't told SolidWorks it's a square yet. So we're going to go ahead and we're going to, there's two ways you can do this. One is you could dimension everything, and that's a completely valid way to do it. But I'm going to show you that SolidWorks also has another tool where you can establish relationships between different parts. And here now it's given me some options for what kind of relationship do I want. And because we're going to make it a square, I'm going to make those two sides equal. So now I don't have to dimension that other part of the side of the square because I've told it that it's going to be equal. And then I'm going to do the same for my other part. And you do that by holding the control key down as you select each of the different elements. And now I have defined it. And now you'll see down in the bottom, it tells me that that part is fully defined. That sketch is fully defined. So I'm going to go ahead and now we're going to exit out of the sketch. And so now I've got my two boxes that I'm going to use to make this square. Now what we're going to do is we're going to extrude this now to take it from a flat plane into a 3D element. And we're going to do this right here on the features. And we're going to use what's called extruded boss face. So now it's gone and it's made it. So it's going to, and by default, SolidWorks will put in 1/10 of an inch. And so now we're going to tell it to do what we want. And we said initially this was a 30-inch, 120-inch frame. So the front sides are going to be 30 inches front and back, and then the sides are 28. And if we add that all together, it should come up to 120 inches if I've done my math right. So we're going to go ahead and put 30 inches. And then by convention, we do all of our extrusions from the mid plane. And so what that means is, and you'll see why this is valuable later on, but by doing it by the mid plane, now this go ahead and extrudes that out. And now we have a 30-inch piece of aluminum that's going to be our front and back of the robot. So I'm going to go ahead and we're going to save that. And I'm going to create a new folder for us here tonight. And workshop. And we're going to call this 30-inch 1x1 aluminum tube frame front. Something so we'll know what it is later on. Because you got lots of parts you're going to start creating, and then all of a sudden you're going to be going back, and if you don't have some sort of naming convention, it gets really confusing very quickly. All right, so now I've got my 30-inch part done, and the other one I needed to make was a 28-inch version of that. So I'm going to go ahead and just save this as a copy, and I'm going to change the name to 28-inch. And then over here, I'm going to come back to that boss extrude. And if I right click on it, it comes up with this fly bar, lets me do all kinds of different things. But I'm gonna, in the top right here, it says edit feature. So it's gonna let me edit that. And now I'm gonna go in here and say, nope, this one is only gonna be 28. And so now I have my 28-inch version of that tube. So I had said earlier that we're going to rivet this together, and the rivet component that I want to use is a VexPro gusset. And so in the interest of time, I'm just going to go ahead and import one that I have previously saved, and we'll use that here tonight. But if you go to VexPro, if you're using anything from Vex or AndyMark or almost any part that you find out there that you're using a COTS, most of them now will have a 3D CAD file in a format that's called STEP. It's a step file. And so you can import that directly into SolidWorks and then add that straight to your model as you're going forward. And so it's a very quick way. So for almost all the COTS stuff, you're just going to be importing your stuff into SolidWorks. In that VexPro gusset, which is a 90-degree gusset, they use a 5/32 inch rivet, and it's on a half-inch center for each of those holes. And so I'm going to go ahead, and in order for us to connect up that rivet, we're going to need to create a series of 5/32 holes in this part. So we're going to select one of these surfaces here. Doesn't really matter which one. And we're going to put some holes in it for us. So we're going to go ahead and we select that face that we want to work on. We're going to come over here to this little symbol in the lower left. It's a sketch, and it's going to let us add a sketch onto that face. So now we're drawing right on the face of this part. And because we want to use a circle, we're going to go ahead and choose the circle tool from that menu on the sketch bar. Now you'll notice that SolidWorks has already drawn a dashed line from the origin because it assumes that you want to put that circle that you're trying to draw somewhere that makes sense, and it says, I bet you want to do it on the center line, and so it does that automatically. So we can go ahead and we're going to add our circle. Now that's a little bit hard to see, so we're going to zoom in on it. SolidWorks, the zoom feature works where it zooms in wherever the cursor is. So I have my cursor right on that hole. So as I zoom in on it, now it's going to zoom in right to that hole. If you want to see the whole part, you can just press the F as a shortcut, and then it jumps right back out if you get lost. But we're going to go ahead and zoom in. So this I've given there's the hole. So yes, it's a circle. And now I need to add a little bit of information on it. I want to add the dimension. Now, I said it's 5/36. I don't know. Does anybody here remember what 5/36 is in fraction inches? It's not required because SolidWorks will do the math for you. And so you just type that in. Now, the other thing, you can also just type in centimeters, millimeters, whatever. SolidWorks will convert it automatically. So you don't really need to worry about the units. You just need to know what they are. Over here on the left-hand side, you can see the tolerance. By default, and you can set this up differently, I just haven't played with it a much, it does 2 digits, but for a number like 5/32, you need all 4 digits to be able to define it in a way that your manufacturing team could look at it and say, oh, okay, I know what to do with that. Otherwise, they might get the wrong information. You can also add tolerances and things like that. There's a lot of power in the program overall. So then we've told it that it's 5/32. There's different ways to do. You can move that around wherever you want. The other thing we need to do is we need to tell it how far we want that to be from the edge. So we're going to set that at 1/2 inch because I told you that's, and you get that from the VexPro drawing that we want to use. So let's see. So now we're still underdefined, and that's because we haven't told, while SolidWorks put that dashed line and put the circle where it thought it should be in the middle, we haven't confirmed that. So now we're going to set up a relationship between the center of that circle and the origin. Whoops. And if you don't quite get what you want, you can hit the escape key and do that. Now I'm going to tell that SolidWorks is asking me what do I want to define that, and I want it to be vertical. So now when I select it, it's vertical. Now you'll see that we're fully defined for that circle. Okay, so that's one, and I need to create a series of these for the gusset. Let me go ahead and open up the gusset so that you all can see what the gusset's going to look like. So this is the gusset part that we imported from VexPro. And so you can see how we're going to have to make those 5/32 inch holes right in a line so that we can put rivets in there. So let's go back here. And so now I've got one, and I want to create more than one. So I'm going to use what's called a linear sketch pattern. And this is kind of a fun tool that lets you use more than one thing and repeat that. Whoops, I got to go over to sketch. Sorry. And you can see here's the linear sketch pattern. So we're going to select the linear sketch pattern. SolidWorks says, okay, what do I want to use as the x-axis? I really want to use the y-axis, or I'm going to use this edge here because I want it to go in that direction. I need 3 of them, and you'll have to take my word for it now. And I'll show you that when we assemble it together. And I want them 0.5 inches apart. Now, right now, they're going the wrong direction. So SolidWorks has this little button here, and you'll see this in a lot of different features when you do mates and all kinds of different stuff. Sometimes you get the orientation wrong. SolidWorks has a way to let you just change that. So now there's the pattern, the linear pattern that I want. SolidWorks still says this is underdefined because what we haven't defined is the rotation on that hole yet. And so what I'm going to do is I'm going to come in here on one of these features, and I'm going to go ahead and fix that. Now, when I fix it, now it's fully defined, because otherwise that set of 3 cuts could have been rotated, and I don't want that to rotate. I want it to just be straight and be fixed. Okay, so now I'm going to go ahead and we're going to go ahead and extrude cut these to make these holes in our part. So I'm going to exit out of Sketch. I'm going to come over to Features. All 3 of them are highlighted because I have the sketch selected, and I'm going to go ahead and extrude cut those. So now I'm going to cut them, and I'm going to cut, I don't want to go through all or mid plane. I'm going to go up to the next. So that's going to go up to the next surface. And so very quickly that cuts that. And now if we rotate that slightly, we can see that SolidWorks has cut through one layer of the tube, but hasn't cut through the other. So in this case, we just wanted to put the holes on the top section. All right. So now, but I want it on both sides, right? Because we're going to use this part for both sides, and they're identical. So I'm going to go ahead and mirror that. And this is where it becomes important. This is where the mid plane comes in, is that we're going to mirror it around the top plane so that it'll mirror, because we extruded it from the center. Now the center of that bar is where we're going to make our cuts from. And this is really important in robotics because a lot of times what we're working with, they're symmetrical, and we're doing the same thing on both sides. We've got our cut extrude number 1, which is what we want to mirror. That looks good. And so we're going to go ahead and accept that. And so now we have a bar. We have our 3 holes on each end, and this bar is ready to go. So I'm going to go ahead and save that one. Okay, now, any quick questions kind of with what we've gone through so far? So we've kind of sketched something out. We've put a cut hole on it. We've extruded it. we've cut, extruded. We've shown how you can quickly add in multiple versions of the same thing for like holes, and we've mirrored it across a sketch plane. So we've done about 6 different things. I know that's a lot of stuff to go through really quick, but quick questions that anybody might have. Yeah, Fred.
Not really a question, but a comment. I'm hoping all the members here are noticing the hierarchical concepts that you're saying, that the menu picks are all indentured logically, and the nomenclatures represent in the industry what you're trying to do. And you might not be real familiar with them, but SolidWorks is among the top 2 for what you're reading is exactly what you're doing. Some of the other packages that I've been able to use, and I pick on Fusion 360 all the time, they have their hierarchical representation is troubling, and their nomenclature doesn't map well with other tools. So it doesn't translate well. It's great for academics, but it's nowhere near as logical and intuitive as this user interface is.
So
and I think I was going to say, when you go back and watch this, be careful and just watch where he's picking and the names of the things. And then as you go through your own exercise of replicating it, you'll be amazed at how much you've already just learned.
So here we're just, so while Fred was making those great points, I was just, the next step is we've got to take the 30-inch bar that we started with, and we've got to add the features on it that we need for our frame. Now, in this case, we're going to go ahead and start with some of the same dimensioning. You can see that I used a different way to do the radius this time. SolidWorks gives you different conventions for how you want to do however you want to do the dimensions. Some of that is just by preference. So then we'll go ahead and make this 0.5 again. So hopefully this starts to feel repetitive. We can slide this around if you want to move it to make it visually easier to see. I like to keep all the dimensions not stacked on top of each other, so that when you're going back and looking at it, it's easier to deconflict what's going on. And then we had one more thing we had to do to make this fully defined. We've got to go ahead and set up our relationship here between the circle, and we're going to make that vertical again. And now we're fully defined. All right. Now we're going to go ahead and do our linear sketch pattern. We're going to do this again here on that edge. We're going to select that edge. 0.5 inches. This time we're going to have 5 of them. All right. And oh, I've got to tell it what we. Uh-oh. Let's try that again. And I find sometimes, SolidWorks does things and you're kind of like, what's going on? And we'll go to 5. Our axis is that edge. And now it did it, because before I didn't have the hole selected, and so that's why it didn't do that. So that's good there. And then we need to go ahead and select our relationship so that we can go ahead and we're going to fix that point. And now we're fully defined on that. Now the other part, that remember that there was that H bar, and we're going to have to put in a hole for a 1/4-20, so that we're going to use a 1/4-20 thread bolt through that to attach that part of the frame. So to do that, I'm going to show you another tool. So I'm going to go ahead and exit the sketch here. Now over in features, there's this thing called the hole wizard. And this is a different way to do kind of what we had done similarly. This will bring up a whole bunch of different hole patterns that you can do for doing different kinds of cuts. Lets you do all kinds of different counterbores, countersinks, all kinds of things that you may want to do with your robot. I'm just going to do kind of something simple here and just select the standard hole. And then you have all kinds of different drill sizes here. All the different drill sizes, if you click on that, it will come up and it lets you do fractional or metric, whatever you want to do. Now for me, for us, when we do 1/4-20, we typically will use a letter F or a letter G drill. Those are just a little bit bigger than a 1/4 inch, and it makes it easier to put the bolt through. And so I've already selected because I was working with this earlier, it remembered what I wanted to do. And so you can see that it's already selected the hole size to be F. But if I wanted to, I could do a straight 1/4 inch hole size, or I could do G, which is just a little bit bigger. For right now, I'm going to go ahead and select F. So that's the size. And now I need to tell it where it's going to be on the part. So I'm going to go ahead and select that here. Now you can see SolidWorks again is drawing the dashed line because it says you probably want to put this hole somewhere in the center. And now I can go ahead and smart dimension where that's going to be on the part. Now I don't have to worry about the hole size because I've already told it the hole size. And for the drawing that we had, we said that was going to be 6 inches. You wouldn't maybe know that, but that's the number that was on the sketch. And again, we're underdefined, so we're going to tell it that those two holes are going to, oops, sorry. Those two holes. That's not what I want to do. There we go. Okay, click off Smart Dimension. And it lets me set that relationship up, and now that's fully defined again. And so now I can say yes, and again, yes. And now I've got my 1/4-20 hole there, and that's ready to go. Okay, so the other piece that we're going to do is we're going to come back over here to my sketch, and we want to extrude that. We're going to do an extruded cut again on that. We're going to go up to next. So SolidWorks remembered what I wanted it to do from last time, and I select, yep, that's exactly what I want to do. And so now I have my bolt hole, my 5 rivet holes, and I'm going to very quickly mirror those again. I'm going to select from this area here. I'm going to select the top plane. And now I have the extrude cut is on there, but I want to add in the, I'm going to add in the other hole as well. So it'll do all of those, it'll mirror both of those features. And now my part is ready to go. All right. And so now I'm going to go ahead and save that. And then as kind of a way of repetition, I'm going to create a new part for our 1x2. So I'm going to create a part, say OK. Again, I'm going to come over to top plane. I'm going to select sketch. I'm going to do a center rectangle. And at this time, it's going to be 1x2 piece of aluminum. So I'm going to make it a little bit rectangle-y. Doesn't really matter what size you select, because when you come in here and smart dimension it, you're going to fix it to be whatever you want. And SolidWorks is very flexible with that. So we said it was 1x2. So there's my 1x2, and that means my interior is going to be 0.75. And this is going to be 1.75. Okay, now, so there's my there's my basic shape. I can exit that now, and now I can extrude this to make that 30 inches. Again, I'm going to go ahead and select by the mid plane. And you can see there's a fair amount of repetition in here. And so now I have my 1x2 that I want to do. So I made those quarter 20 cut holes in the other frame. And so this one here is going to mount to that. So I'm going to go ahead and use my hole wizard here again to do that. And my position, I'm going to go ahead and put that here on this frame. Again, it's going to do that right in the center. Now, in this case, I'm going to make it a 1/2 inch, so it's kind of like right in the center of that 1 inch bar. So I'm going to go ahead and zoom in on that, and I'm going to smart dimension that to be 0.5. And then again, I'm going to make, oops, I'm going to exit out of smart dimension. I'm going to select that, then zoom in here, control click that, and make that vertical. So again, fully defined. And then back to my hole type, it remembers F, and so that's easy. That's exactly what I want. And so I say, yep, that's what I want, and it cuts my hole. Now, a 1x2 connecting onto a 1x1, we want to cut a notch out of the 1x2 so it'll sit on that frame. And so I'm going to go ahead and spin this around. To spin it around, you use the wheel on the mouse. And now I'm going to go ahead and I'm going to do a sketch on this piece right here. However, now instead of using a center rectangle, I'm going to use a corner rectangle, and I'm going to put it right there on that corner and draw my square. And now we can dimension that real quick so that that's going to be 1x1, and then that other frame is going to sit right in there like that. Okay, so now I've got that. I can exit out of this, and I'm going to do an extruded cut on that. And this time I'm going to go through all, because I just want to cut through that whole piece. And I click on that, and now I have a nice little notch with my hole for my bolt there. All right, so I'm going to head and save that now. So this is a 30 inch 1x2 aluminum tube frame. We call this like an H frame, and so I'm going to just call this the H. All right. I've got that, and I've got that. Now I need to mirror those two features. Again, around the top plane, and I need to add in both the cut extrude and that hole. And now I should have 2 notches on there. Perfect. All right, now I'm going to go back to the 30 inch part, which was the front and the back. And I'm going to come up here, and I'm going to make an assembly. Now we're going to assemble this frame together. So we can go ahead and make an assembly from that part. And what this is going to create is kind of the next stage in the process, where we're going to start assembling all the parts that we have together. So it's going to add in my part here, and I'm going to go ahead and put that right there. All right, now I need, it's important to kind of notice that whoops, I didn't realize this was a touch screen. So when I went to point to it on my screen, it actually moved it. So we can get our orientation. We can SolidWorks will let you move the part around and see it from whatever direction you want. But we're going to go ahead and add a couple of different versions in here so that we can build our frame. So there's one. All right, now I'm going to add in the sides. which I think I see that I messed up the. Now this is, we want to make a square, so I don't want it in this configuration, so I can come down here and I can rotate it till I get it about the right location. It's not important for it to be perfect, and we're going to fix that in a minute, but it's easier. I think it's easier if you're in the general location for the next step. So the next step, and you can kind of see, is these are all pretty close, but we're going to go ahead and do what's called mating. And so we're going to mate together the different parts to create our frame. And so I'm going to mate this side here. And then we're going to zoom in, and I always find just zoom in as far as you can. And then SolidWorks moves the part around to exactly the mate that you wanted. Now you can see those two surfaces are mated, but they're not really mated the way that I exactly want them. So I'm going to add a few more mates here. I'm going to mate the top of these sections together so that it's at the same elevation. And then I'm going to mate these two ends here. And now you can see I've made one corner of my thing. So I'm going to do that for, I'm going to go F, and that brings it into this. And now I'm going to go ahead and do that for these parts here real quick. Sometimes it's a little bit hard to select, and so it's good for you to just zoom in there. I want these two surfaces. So there's 3 mates on each one of these corners that we have to do to fully define that. Okay. Now we're going to come back out and zoom back out. I'm going to do one more here. And you can see SolidWorks gives you a bunch of different options for different kinds of mates. We're using tonight what's called a concentric mate. And that's a pretty standard mate for what we want to do. And then now this one here, we want this to be on this side. So we want it to be here. And you can see SolidWorks is kind of makes it a little bit hard, but I can get in there and put that mate. Now you'll see that we're fully defined because I've defined, whoops, what did I do wrong? Oh, that's funny. All right, so I didn't put this mate over here. Should have been on the inside, right? And not where it is. So I'm going to go ahead and close out of that. You can come over here and take a look at your mates. And I can come down here and I can see, well, that mate isn't the one that I want there. The top mate, that's good. And this other mate is the wrong mate too. So I'm going to go ahead and delete that one. And then I'm going to delete that one. So it's very flexible. You make mistakes, you're going to come back in here and fix it. And so now I need this surface to be mated to this surface. All right, and I need this surface to be mated here. All right, now I think that looks more like a square, right? Now let's go ahead and bring in our gusset that we want to use. And again, I can rotate this to, that's the wrong, but that'll work. And I'm going to put that right there in space. And then I'm going to use the mates to line that up. So first thing I want to do is I'm going to mate this surface here with the bottom of the gusset that I want to use. All right. And then I'm going to use a little bit different mate here for this one because I want these holes to line up exactly. I'm going to select that hole, and then I'm going to come over here and select this hole. and it's going to let me do what's called a concentric mate. So it's going to mate those two holes. Now, what you'll see here is that I can still move this around. So I need to do 2 concentric mates to make that happen, to fix it, and do that. And then there's my gusset. So there's a very quick how you would then mate those things together. And then let's bring in our other H member. So we're done with mates for now. We're going to insert one more component. We need the H frame. I'm going to go ahead and zoom out. But first we're going to rotate it so that it's in the right direction. Let's zoom out, and I'm going to insert one more version of that. Now you could put this pretty much anywhere in space, and if you bring it into the part in the wrong orientation, you can use the mates pretty easily to fix that. Again, I'm going to go ahead and I want this to ride on top of the frame, so I'm going to mate that piece. Oops. Sorry. To the top, just like that. And then I have to mate the edges because I want those edges. I typically don't want to select faces. You know, so edges, you typically want to use the face. It's easier that way. And so there's that. And now I want to put it into alignment with the hole. So again, I'm going to use another concentric mate. Oh, there we go. It told me I wasn't paying attention to what I was clicking on. So there we are. That's it set. So let's go ahead and zoom back out. Sorry. And I'm going to bring this part over here to about where I want it, make it easier to manipulate. Again, I'm going to select that. I'm going to flip it around to the bottom side. And that's one mate there. And then I can zoom in and select that. And now I just need to get my concentric holes lined up. Oops, sorry. Got too fast clicking. We're going to select mate. And concentric. There we go. All right, so now I pretty much have my frame. There's my basic frame. Oops, looks like we've got a problem there. And so we would need to go figure that out.
Your bar on the one side is actually intersecting the top and bottom ones. You got the wrong face
Yeah,
joint.
I think I got the wrong mate on there.
Yeah.
We'd have to go fix that. Sorry about that. But I think you get the hopefully you get the basic idea. And then from here, if we wanted to go, the one other quick thing that I was gonna just show you real quick is that, again, if I go back to this part and I want to send this over to your manufacturing team, you're going to make a drawing out of that for your manufacturing team. So again, you go to new and you can select that to say, I want to create a drawing. SolidWorks will bring up that drawing, ask you what size you want. I'm just going to go ahead and select OK on this. It does a lot of the stuff in the ISO standards, and so it's a little bit, if you use the A sheet, it's pretty close to what we need. On the right hand side, you can see that it comes up with the shapes that are there, and so we're going to pick the ones that make the most sense for what we need to tell our manufacturing team. And I'm going to select the left and the back for that. lets you put them kind of anywhere you want. Sometimes, we like to do the ISO just because it helps out a little bit, and then that gives you kind of your basic drawing, your basic layout, and then you can come in and do your dimensioning to tell the manufacturing team what are the key things that you need to know about this. I think I selected the size way too because it's coming in really small. And so you could then dimension out all the different pieces that you need to for your manufacturing team. One of the things to note in the you can also do your hole call out. So here we want to give the information to the manufacturing team exactly on that hole. You can use that hole call out feature, and it'll tell you exactly what you need to know about that. Again, you might want to come over and adjust the tolerance on that, so your manufacturing team or your build team knows exactly what you're talking about with the different size drills and what might be available. Okay, so that was kind of a whirlwind tour, I think, on all the different things you can do with SolidWorks. I'm going to go ahead and stop sharing there, and just so that we can kind of catch our breath for a minute and see if anybody has any questions or things that you wanted to ask about SolidWorks, or what you may not have seen that you would be interested in.
So Andy, I'll make another plug for a hardware device.
Yeah.
This is a 3D space mouse, which makes it a whole lot easier to navigate around in any of these 3D design packages. They're not, I don't remember how much these cost, but they're, all of our mechanical engineers use them. I've gotten kind of used to using it, but they really make, it gets a little frustrating, as you could probably see there, trying to manipulate things around in 3D by clicking mice in various places, and this thing makes that a lot easier. So
Yeah, that's a great point, Jim. I think it's,
yeah. But very, very good presentation. Thank you.
yeah, I just wanted to kind of cover some of the basics and what you can use this tool for, and how that can be helpful for your programs. Like I said, lots of resources. I'll include those links in there. Other questions?
Where does prototyping fall into in this whole like SolidWorks process? Do you find yourself designing something before you prototype, or the other way around, or how's that work?
Yeah, great question. I think what we do in practice a lot of times is we will be very quickly moving in two directions, and so the CAD team will be starting to put the design together in the SolidWorks. We will often build what we call a blob bot in the very, very early days, which is really kind of a notional representation of where the different game manipulation elements are going to be. Like, where do we think that, what kind of chassis are we going to have? Where's the electronics going to go? Was the ball pickup, from this year? Where's the climber? Where's all these things? How are they going to start to fit together? But then as we look at the actual mechanisms, we'll be prototyping both in the electronic format and the physical. The physical we use to kind of make sure that we understand if the mechanism's going to work the way that we think it's going to work. Like if you have a ball pickup mechanism, or you want to pick up those cones, and we have an idea, so we'll prototype a couple ideas for how we might pick up the cones, what that might look like. At the same time, the CAD team is starting to do some of the design work to get you there, so that if the cones are successful, it goes straight into the robot. If not, then usually you're left with enough in the CAD that you're starting to tweak or make the changes that you need to. Does that answer your question?
Yeah, definitely. And how big would you say your CAD team is? Is it just a couple people working on it, or like large majority of the team?
Yeah, another good question. I would say that has changed dramatically over the years. So it used to be 1 or 2 people was the CAD team. Now we have 8 CAD workstations, and we'll try to get as much, especially in like the first 2 or 3 weeks, almost everything is in CAD except for that prototyping that we need to do to kind of explore concepts and get an understanding for how it's going to work. So I would say that we've morphed from being a where CAD was kind of following the design and documenting it to the point where now CAD is leading more of the design work, and we do much more of that in CAD now because it's faster and it's cheaper, and it's easier for us to iterate on ideas in the CAD tool versus doing it physically, which just takes a lot of time. Prototyping is fun, but it takes a lot of time.
All right, thank you.
Yeah, great questions. Anything else? How about from the gearheads? How are you guys doing? All right, good. Very good. Well, we'll go ahead and if there's no other questions here, feel free. You have my email information. Let us know. We have a couple of mentors that are really good at this stuff. I'm at best an amateur in CAD, and so but I think I hope you get the impression that I think this is something any high school student can do, and I think it's an incredibly important skill to develop, and I think it really helps your team build a robot that fully embodies what you guys are capable of. So best of luck. Hope this has been a little bit helpful, and like I said, I'll post this information and we'll send it out. So thanks everybody. Have a good night.
Good night.
Good
Hey,
night.
Andy.
Yes, sir.
Thank you.
Andy, is the video going to be available for folks that couldn't